Hello, this is our video for EA5 about scaling both axes with a consistent scale. We're kind of adding to what we started down here. That is step 4 on making a graph. Scale axes with a consistent pattern starting from 0. We had some clues on this how to do that, but here we're going to add to this because this is such an important thing. We want to make sure that we're thinking about it at all times. So these two clues say always use a consistent scale, increase numbers by even jumps, and this also says for this class always start at 0 on both axes. So for example, this would be not consistent. I'm going to give you an example of a graph that is not consistent. If we took these numbers and we said, okay, width in units of centimeters on this axis, and then we just chose these numbers and we said, all right, 5, 8, 10, 16. This is not consistent. If we took these numbers on the force axis and we said that force could be measured in, say, 10, 6, 4, 2. This doesn't go up from 0, and it definitely is not consistent. The number of the total amount of number between 6 and 10 is different from the difference in number between 2 and 4. If we think of this as, okay, if we're labeling this as 0, there are 2 boxes from 0 to 5. There should be 2 boxes from 5 to 10, not 5 to 8, and then from 10 to 15. So this is an example of something that is not consistent. I'm going to show you another example of something that is not consistent. If we look at this graph, we have 2 parts of the question here. One of them says, underline anything that applies to the student's graph and circle one rubric box. A lot of people circled that this was a solid graph, and it is close. It is labeled perfectly. It's got a great title. The independent variable is on the x-axis, and the axes both have correct labels. The points are plotted but not connected. All of that is right, but I don't think that the graph is consistent starting from 0. I think that either the scale didn't start at 0 or it wasn't consistent. I think that this would actually be a struggling graph. I mean, it is so good I would probably end up giving it a P, but it is definitely not an M because it doesn't start from 0 or it's not consistent, one or the other. I'll show you why. I like to call this the Drake graph, as I mentioned in class to some of you, because on the x-axis, it is consistent. It goes 0, 5, 10, 15, 20, 25. We can see that each box corresponds to 5 degrees. And most of the y-axis is consistent. It goes from 100 to 120, 120 to 140, 140 to 160. That is, it seems like each box is equal to 20 milligrams. This part of the graph is consistent. However, notice that even though it goes from 100 to 120 and 120 to 140 very gradually, like one box at a time, this graph goes from 0 to 100 real quick. That is, there is much less space than there should be between 0 and 100. Now, take a moment to laugh at the joke. If you're still laughing, that's okay. It is a very funny joke, but it's also a really good way for us to remember that we never, ever, ever want to go from 0 to 100 real quick. We want to make sure that we give ourselves a consistent axis. So we're actually going to include this precise graph as an example in our notes as well, because we want to make sure that we don't go from 0 to 100 real quick. Exclamation point. Make sure that you don't make that mistake. This one could go, if we want to make this a temperature axis in degrees of Celsius, and then maybe this is the mass in degrees of, I'm just going to write mg to abbreviate milligrams. This is also not consistent if we go from 5, 10, 15, 20, 25, and so on. That's okay. We already know that that works. But going from 0 to 100, then 120, 140, etc., 160, 180, we don't want to do that. So this is an example of something that will earn you not as many points as we want. We want to make sure that our graph is consistent, increasing from 0. Take a moment, and if there are other things in any of these graphs that are going to help you here, they're going to help you make your graph consistent, that are going to make your graph perfect, write some things that are going to help you here. If you want to include another example of something that you did that you had a hard time with, then do that. I'm going to show you my solution to this question here. If you haven't done this question yet, you should try to do it before you continue. You should pause the video. If you're really serious about doing well in this test tomorrow, you should pause the video and then finish this, that is page 6 of your packet. Try to do it and then come back and look at the solution I'm about to show you. So if you haven't done it yet, you should not go forward. You should actually try to do this work so that you can check your work. Once you've done that, you can go ahead. Here's the work that I did. I'm going to just show you these answers. Research question, independent variable, dependent variable. Lots of controlled variables could work here. The kind of bread, the time taken to grow, all kinds of others could work also. The idea is like, what do we want to hold constant for this experiment? It could be like the amount of light in the container, the amount of humidity in the container. That is lots of things we want to be constant. The only thing we want to change is temperature. Then I'm going to leave it on here for a while so that you can actually look at this for a while. We definitely see a relationship. If temperature increases, the math of mold growth increases. And your graph should look something like this. I decided to put a trend line on this because it looked like it was a line relationship. That is, like, it looked like I could put a line through these points and that would show the pattern that we were seeing. But if you see a pattern that doesn't look like it fits a line, then you may not want to actually add this line. We'll talk more about that later.